All right, today for algebra we're doing 1.5, multiplying rational numbers. So our objectives today are we're going to multiply the signed integers and rational numbers. Remember, rational numbers means like fractions and decimals. Integers are those positive and negative numbers. And we're going to identify and apply the properties of multiplication, in which we have a lovely chart of. One thing to remember is a factor times a factor equals a product. So if you hear the term factor, you know that you're going to be multiplying some numbers together. So just a reminder, if you hear factor and product, we're talking about multiplication. All right, so before we can apply the properties of multiplication, we need to review what they are. So the first one, we have the commutative property of multiplication. Okay, and that is just like we multiply numbers in different orders. Okay, we can multiply two numbers in different orders. The product is the same. The associative property of multiplication gets at where we group our numbers. Okay, so we can group our numbers differently, but again, the product or the solution is the same. Okay, multiplicative identity property. Okay, this is the product of any number and 1 is that number. So 5 times 1 equals 1 times 5. That's that commutative, which equals 5. So A stands for any number, right? Any number times 1 is equal to 1 times any number. It's always going to equal A, any number. So whatever number you put in there. The distributive property, we're going to use a lot this year and in all of your future math classes, but it's the product of a number and a sum is equal to the sum of the products. So remember, we're just distributing that number. We're sharing the number on the outside of parentheses with each one. So A times B is AB. And then we're going to distribute or share the A with the C, so we get plus AC. And the last one, the zero property of multiplication. So this is the product of any number and 0 is 0. Okay, so you've known all of these properties for years. We're just looking at them and reviewing them. Okay. So next up is a little chart that I use to help students remember multiplying and integers. Okay, positive and negatives. So if factors are both positive, so we've got two positive i's here, or they're both negative, so we have some negative i's, then our product, or the answer, is positive. You get a nice little smiley face on both of those. Now the opposite of that would be is if one factor is positive, so in this first one, right, we have a positive, and the other factor is negative, then the product is negative. So he's got a sad face, he's got a negative. On the other one, if you have a positive come first and then the negative, the order doesn't matter, it's still a negative answer. Okay. So, example 1, let's try some. We have -2, so we have a negative and a positive times a positive. Okay, it's a positive 9. So we have a negative and a positive. Our answer is going to be a negative. So 2 times 9 is 18. On B, we have a -3 times a -6. So we have a negative times a negative. It's the same sign, so it's going to have a positive answer. So 3 times 6 is a positive 18. And the last one, 2 is a positive number. 5 is -5, so that's negative. If we have a positive and a negative, then we have a negative answer, just like this one. So this would be negative. 2 times 5 is 10. So it's -10. All right, so then we have this question, well, what if there are more than 2 factors? Well, if we have an even number of negative factors, then our product is positive. So you have to remember, even is positive. Okay, if we have an odd number of negatives, then our product is negative. So odd is negative. So let's look at that. In this first problem, we have 2 times -4 times -3 equals 24, it says. We have the 4 and the 3 are both negatives. So we have two negatives, which means it's an even number. So our answer is a positive. Whereas in the next example, 2 times negative 4 times 3, we only have one negative, which 1 is an odd number. Okay, 1 is an odd number. So because we only have one negative, our answer is also negative. It really is that simple. You have to look at are there an odd number or an even number, because negatives cancel each other in multiplication and division. So let's look at example 2 down there. Okay. Sorry, I had to move my camera this time. All right, there we go. Example 2 says multiply. So we have a negative, a negative, and a negative. So we have three negatives. So 3 negative numbers. That's odd. So our answer is going to be negative. Okay, so then we're just doing the math. So we have a negative answer. 2 times 3 is 6. 6 times 5 is 30. So it's negative 30. Here in B, 4 is positive. 3, we have negative 3 is negative. Negative 1 is negative. So here we have two negatives. That's supposed to say negative. Okay, so two negative numbers. Two negative numbers is even. Since we have an even number, then we know our answer is going to be positive. So 4 times 3 is 12. 12 times 1 is 12. Okay, and you can check that too as well. Like if we were doing this, we could say, okay, well, 4 times negative 3 would be a negative 12 times a negative 1. These have the same sign. A negative times a negative is a positive 12. You could also do it like that and not do the shortcut. So the same way here. Okay. Negative 2 times negative 3, they both have a negative. So that means it'd be positive 6 times negative 5. Now you have a positive and a negative. So you have a positive and a negative, so you're going to have a negative answer. So it's negative 30. Okay, so it kind of just depends on how you want to solve it. But you're going to get the same end result. All right, let's check the back. We're going to keep going with this. Example 3, we're doing decimals, and 4, we're doing the rational numbers. Okay, so remember for decimals, we don't have to line them up. We just count our decimal places. So 4.28, 5.31 that we're multiplying here. Okay, and sorry, it's a negative, but I'll put that, I don't like to put the negatives here because I don't want it to think it's a minus problem instead. So we're ready for our long multiplication. 1 times 8 is 8, 1 times 2 is 2, 1 times 4 is 4. Remember your 0 placeholder. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8. 3 times 4 is 12. 2 0 placeholders now. 5, let me cross out that 2. 5 times 8 is 40. And 5 times 2 is 10, plus 4 is 14. 5 times 4 is 20, plus 1 is 21. Then we add all those up. 8 plus 0 is 8. 2 plus 4 plus 0 is 6. 4 plus 8 plus 0 is 12. So 2, carry my 1. 1 plus 2 is 3, plus 4 is 7. 1 plus 1 is 2. And then we just bring down a 2. Now, it might have been a while since you have used multiplication of decimals. I'm not for sure. Remember, we count over, so there are decimals 2 places over in the first problem, or first number. 2 places in the first number, so that means it's 4 places total. So 1, 2, 3, 4. So for example 3a, we have a negative times a positive number, so our answer is going to be negative. So it's negative 22.7268. All right. Now for B with our fraction numbers. We've been working on fractions in enrichment math. So it should be a little bit easier. But we have a negative times a negative, which means it's a positive. So then we're ready to just multiply. 3 times 7 is 21. 4 times 8 is 32. So 21 over 32 is our answer there. So again, we're still doing the same thing that we're multiplying the decimals the same way as always, multiplying rational numbers the same as always. We're just adding in the integer, okay, whether it's a positive or negative. All right, next up, example 5, we're going to multiply. But notice we have some mixed numbers here. Excuse me. We have some mixed numbers here. And then B, we have rational numbers. We've got this lovely box. When multiplying fractions, always reduce and cancel first. That's going to keep your numbers small, so there are fewer mistakes. So in this example, it says cancel, then multiply. All right, so we could cancel here the 7 and the 14. Right, a 7 goes into both of them. So 7 divided by 7 is 1. 14 divided by 7 is 2. We could also cancel the 12 and the 3, because 3 goes into both of them. 3 divided by 3 is 1. 12 divided by 3 is 4. So now we're left with 4 times 2, which is 8, and 1 times 1, which is 1. So here, we got this lovely answer of 8. Versus having to actually take the time to multiply 12 times 14 and then to reduce it. Okay, so we want to try that on example 5. Okay, let's make sure we're canceling, reducing and canceling. All right, so first of all, mixed numbers have to be in what shape so that we can multiply them? Good, they have to be in proper fraction. So 5 times 2 is 10, plus 1 is 11. 7 times 4 is, excellent, 28, plus 2 is 30. So 37ths. What cancels? What cancels? Good, the 5 and the 30 can cancel. So 5 divided by 5 is 1. 30 divided by 5 is 6. Anything else cancel? No. So 11 times 6 is 66. 1 times 7 is 7. And you're done. You don't have to put this in that mixed number form, remember? As long as it is reduced or simplified. There's no other common factors, so this, you know, is as small as it goes. All right, let's try B. Negative 3/4 times negative 18/7. Okay, so we've got a negative times a negative, so our answer is going to be positive. Can we reduce anything? Or cancel? Yeah, right? The 4 and the 18 both have a 2 in common. So 4 divided by 2 is 2. Excellent. 18 divided by 2 is wonderful. 9. Well, do we have anything else in common? Nope. So we're just going to do it. Now we know our answer is positive because it's a negative times a negative. So 3 times 9 is 27. And 2 times 7 is 14. All right, so 27/14 is your answer there. And it is already reduced as far as it will go. All right, next up we have unit multipliers. You will use these more in science, but we will also use them in math. Okay, a unit multiplier is a fraction. First and foremost, it's a fraction with two different expressions for the same quantity, okay, in the numerator and the denominator, which may seem weird, but it's just a fraction that's two different ways to write a relationship. So the unit multipliers are equal to 1 always, and they're used to change the units of a number. So if we want to change from miles to kilometers, or if we want to change from Celsius to Fahrenheit, if we want to change from minutes to seconds, okay, we're changing the unit. So let's look at some of the examples. Okay, here are two different unit multipliers. So each one is a fraction. but they have two different expressions for the same quantity. Okay, so they say, well, 12 inches is equal to 1 foot. That's true. Or you can say 1 foot is equal to 12 inches. That's also true. You just stated it differently, but both are equal to 1 because they're the same measure, or they're measuring the same thing, just using a different tool. Okay. Another one here that we can look at, okay, says 16 ounces is equal to 1 pound, or 1 pound is equal to 16 ounces. They're the same thing. They're both equal to 1. There's just two different ways to state the information. Now, where this comes in handy, so in this example in the box here, we have 60 inches and we want to convert it to feet. Okay, so right here we want to change it to feet. So we use a unit multiplier. This thing right here is a unit multiplier. We use a unit multiplier to cancel and convert it. Notice we had inches, 60 inches, so we picked the unit multiplier that had inches in the denominator. Because if it's in the denominator, and this number's in the numerator, we don't think about it always, but it's over 1, the numerator and the denominator cancel. So the inches cancel. Now, it just so happens that here 60 and 12 are common, so 12 goes into 12 once, 12 goes into 60 5 times. And so 5 times 1 equals 5 feet. The other part of this is showing the other way. If you had 5 feet and you want to convert it to inches. This time you pick a different unit multiplier. You pick the opposite one with the feet in the denominator, because then your feet will cancel. And now you have to do 5 times 12, which is 60. And this is 1, right? 1 times 1 is 60. So you'd get 60 over 1, which is just 60 inches. Again, it may not make the most sense looking at that example, but let's try the next 3. Example 6, we're going to convert the following lengths, and we're going to use unit multipliers to do it. Okay, that's the thing in your homework. There's some you could do without, but I want you to practice. So we're going from inches to centimeters. So I'm going to start with 52.25 inches. That's what I have. Now I need a unit multiplier, or a fraction. Because I'm looking at inches, okay, I want inches in my denominator. So how many centimeters is equal to an inch? Good. I knew that you guys would know it. 2.54 centimeters equals 1 inch. And again, the reason that I chose inches in the denominator was so it would cancel here. So now you do 52.25 times 2.54. And that gives you 135.255. And what's my unit? What's the only unit that's left up here? I had inches, centimeters, and inches. Which one remains? Centimeters, right? We canceled everything else. So we know we set it up correctly. Okay, let's do B. We want to do 51 inches to feet. So let's check it out. We have 51 inches times. We need inches in the denominator, and we're converting it to feet. So the feet are going to go up there. We want inch in the denominator because it's the value we were given in the numerator of 51 inches. So our inches will cancel. We're setting it up that way. Okay, so how many inches are in a foot? Good. So there's 12 inches in 1 foot. So now we do 51 times 1, which is 51, over 1 times 12, 12, so 51 twelfths. And we could get an average of that. Oh, I should have canceled, but that's not an easy one to see, like 13 or 12 and 51. 12 and 51 would have canceled. They both have a 3 in them. So this would be 4. and 51 divided by 3 is 12. Again, no, not 12, 17. Not the easiest one to see. Sorry, this is 17. So that would equal 17/4 feet. Okay, we have one more. We're going to do miles to inches. Miles to inches. So I've got 2 miles, right? This is like over 1 times, remember, I have miles in my numerator, so what do I want in my denominator? Good, I want the miles. And then I have inches. Sometimes I have to do 2 steps because I don't know miles to inches. I do know how many feet are in a mile though. So there's 5,280 feet in 1 mile. Okay, so I've got my miles to cancel. But now I'm stuck with feet and I want inches. So I can do the math or I can go ahead and put another unit multiplier here. So now I'm stuck with feet. My unit multiplier is going to go feet to inches. So I want feet in my denominator, so it will cancel, which means inches has to go in my numerator. All right, and I know that 1 foot is equal to 12 inches. And my feet cancel, and I'm left with inches, which is what I wanted. So now I need to do 2 times 5,280 times 12, which is going to get me 126,720 inches. Okay, but again, unit multipliers are so you can go through and cancel out your units so you can change a unit. So again, here we went from miles to inches. In B, we went from inches to feet. And in C, inches to centimeters. We're converting our units or changing. All right, there is your homework and your notes for today, and you can get started on your homework. Have a great day.